So if you remember last class, we ended with just a short discussion about this communications scenario where we have a vehicle and we have a cell tower and they're trying to communicate to each other. And I use this as an entry point to talk about antennas. And one of the things that we finished that discussion on is this idea of parametric design. And I just wanted to remind you of the scenario because today's focus over the next day or two while I'm out with these recorded videos are going to focus on describing what parametric design is in the context of making the antennas. We didn't talk too much about the antennas here, but you see the result of the antenna in what's called the gain pattern that is very critical in the communication element. So the focus of these next batch of videos, however many I end up with today, are really just going to be focusing on building of the antenna so I can introduce this idea of what parametric design is and what it does. We're just going to focus on a very simple antenna. As you're going to see, we're going to use the half-wave dipole. We'll build it first, maybe a traditional way, which would, or I should say, just the non-parametric way. We're going to rebuild that same antenna using parameters. And then I want to introduce to you what the power of the parametric design is in that final application where we actually run the parametric analysis. So this is the focus of the next few videos. This is the objective. You already know Maxwell 3D. We're going to introduce something called HFSS, and you're going to be happy to see that manipulating that environment is very similar to Maxwell 3D. So knowing how to move components around in Maxwell 3D is actually going to be a big benefit to you now that you know Electronics Desktop a little bit.